MDMA is like a mixture, a chemical mixture, if I can say that, structurally speaking, between a mescaline, a classical psychedelic, and a methamphetamine. So I mean, it's like MDMA could do something similar to what both mescaline and methamphetamine do. And
I see. MDMA is methylene dioxymethamphetamine. You're basically saying, from a structural standpoint, it's sort of somewhere in between methamphetamine and mescaline.
Mescaline, yeah. And again, there were several studies in the 90s, even 80s, testing the behavioral pharmacology of MDMA and back to the question about the isomers. And some were proposing that the S was more amphetamine-like and the R was more mescaline-like, but depending on the behavioral model, others proposed the opposite. So again, the question was still open. I mean, and again, most importantly, I mean, that was before we kind of were convinced, if I can say that psychedelics could be used therapeutically. And now, I mean, you know this, I mean, one of the phenotypes that we think predict or suggest that the drug could be used therapeutically is their effects on a structural plasticity in the cortex. So that is something that we tested, you know, how these two isomers, the R and the S, affect plasticity in mice, and we saw interesting differences between both.
Got it. So we've got these two versions of MDMA, S and R, the left-handed version and the right-handed version, but we'll just call them S MDMA and R MDMA. Many drugs have these two versions. This is very common. Ketamine is like this. You know, LSD you mentioned has 4 different versions because it's an even more complex structure. So you've got 2 versions of MDMA. The question is, do they do different things? Do they have different behavioral effects in animals? Do they feel different when people take them? Do they have different effects on plasticity, and so on and so forth? There was some hints in the literature that perhaps S and R-MDMA had different effects in animals, but the results were a little ambiguous or conflicting. But a priori, like without knowing anything, is it common for different isomers to have different effects? Like would we expect them to be pretty close to identical in their effects, or would we expect them to have some kind of difference in their effects?
Usually they behave differently. I mean, both molecularly in tissue culture, in cells, and also in animal models. They usually induce different effects behaviorally and in terms of signaling, cell signaling.